Here are some word problems with ellipses. I've got so many things open, I don't know what to do. I'm like the little old lady who lives in a shoe. And the exercise is, it says, find the standard form of the equation of the ellipse given these properties. So number 20, and by the way, this is homework for on-ramps pre-calculus. Number 20 says, all points on the ellipse are in quadrant 4 except 0, minus 6, and 10, 0. 10, 0 sounds like Tanjiro from Demon Slayer no Yatsu. But anyway, okay, so I'm going to say this is 5, 10, 5, 10, 5, 10, 5, 10. Okay, so 0, 9, and 6 is about there. There's 0, minus 6. And 10, 0 is about there. There's Tanjiro. 10, 0. So this thing, this has to go all the way to 20, I think. Wait a minute, I've got to make this bigger. It's like a 5, 10, 15, 20. It goes somewhere around here. So yeah, this thing looks like that. Well, something. I'm not an artist. It looks something like that. All right, so it's one of these ellipses that's longer than it is wide. It's a horizontal ellipse, which means that the longer number goes under the x part. Well, the center is 10, negative 6, because it's 10 over and 6 down. So I have x minus 10 squared plus y plus 6, because it's minus 6 is the coordinate, squared, and of course it equals 1. Now I need to find the a and b. Well, this is going to be a, so it's 10 and 10s, because to get here from the y-axis is 10 over, 10 over. So a equals 10. So this is a squared, which is 10 squared, which is 100. And then b is 6, because I go 6 down to get to 0 minus 6, 6 down to get to the other edge of the ellipse. So this is 6 squared, which is 36. And so that's the standard form of the equation. And if I go to Desmos, and I find Desmos here, and I'm going to put in this equation, x minus 10 squared. I'm just checking it, because at homework time I could check things. Maybe you don't have a calculator during the test, but if you do have a calculator, you might as well check it to make sure you got the right equation. And sure enough, check it out. It's got a point at 10, 0, and a point at 0, negative 6, and everything else is in the fourth quadrant. So you had to know, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. You had to know that. But anyway, there's the equation. X minus 10 squared plus y plus 6 squared. X minus 10 squared is over 100. Y plus 6 squared is over 36 equals 1. Next one. An elliptical arch is constructed which is 6 feet wide. So that's 6 feet and 9 feet tall in the middle. So there's the middle. It's 9 feet tall. Maybe that's a pretty good representation. Maybe not. It almost looks like a bishop's hat or something. Get rid of that. Okay, so the base is 6 feet. That makes this 3 and 3. And the height in the center is 9. Okay, so this one, this is 6, this is 9. If I complete this ellipse, this is one of these that is taller than it's wide. So that means the A goes under the Y part. So where is the center? Well, I'm just going to call the center 0, 0. So I'm going to go x squared plus y squared equals 1. And then I've got to find what the, oh wait a minute, it can't just be x squared and y squared. Can it? Oh, this one doesn't want the equation. It says find the height of the arch, exactly 1 foot from the base. Okay, let me finish the equation, that general instruction. Okay, so I know that the A part, or the A part is the longer part, is 9, so 9 squared is 81. The distance from the edge to the center is A. The distance from the edge to the center on the minor axis, the shorter axis, is B. 3 squared is 9. So that's my equation, x squared over 9 plus y squared over 81 equals 1. Now, I want to find the arch 1 foot from the base. So if this is 0, 0, this is negative 3, 0, because that's 3 away from it, and this is 3, 0, 3 to the right of it. 1 foot from the base would be 2. The x-coordinate is 2, and I want to find this y-coordinate. I want to find how high it is. So this is going to be 2, and then some value of y. And this is going to be, over here, minus 2, some value of y. Either one of those points is 1 foot from the base of the arch. Doesn't matter which one I use, I'll use 2y. I'm going to plug 2 in for x, and then y in for y. So this is 2 squared, which is 4 over 9, plus y squared over 81 equals 1. And if I plugged in negative 2y, negative 2 squared is 4, so it would come out exactly the same. I think I need a little bit more room. So now I will subtract 4/9 from both sides. Y squared over 81 equals, I'm going to write 1 as 9/9, so I can easily subtract, minus 4/9. I subtracted 4/9 from both sides equals 5/9. So y squared over 81 equals 5/9. Now I will multiply both sides by 81 to get rid of this. Y squared equals 5/9 times 81. Well, 9 goes into 9 once, 9 goes into 81 9 times. 5 times 9 is 45. So y squared equals 45. And y, I just take the square root of both sides, is the square root of 45 equals, 45 is 9 times 5. The square root of 9 is 3, so 3 square root of 5. So that's the height exactly, 3 square root of 5, and I can throw that into Desmos or into your calculator, is about 6.71. More room is approximately 6.71 feet tall. So here it's 6.71 feet, and here it's 6.74 feet, one foot away from either edge. So those are a couple of word problems with ellipses.